We begin a short question answer session on mechanics in lecture number 5, and our first question is as follows. Two solid spheres of same uniform density fall from rest under gravity in a viscous medium and after some time reach terminal velocities v1 and v2 respectively. If masses are respectively m1, m2 and v1 equal to 4 times v2, then m1 by m2 is, and the options are, option A is 1 by 8, option B is 1 by 4, option C is 4, and option D is 8. The answer: a particle falling in a viscous medium experiences forces like number 1, downward force due to its mass, call it Fm. Number 2, the upward buoyant force, call it Fb. And number 3, the upward viscous force that opposes its motion, call it Fv, and it is given by Stokes' law. Most importantly, this term Fv contains velocity. So the one-dimensional force equation is Fm minus Fb minus Fv equal to mass into acceleration, that is m into a, and a is given by dv dt. With time the particle accelerates and the velocity increases, but it follows from the force equation that the net force decreases due to the negative sign situated before the viscous force part Fv, and hence after some time, for some v equal to vt called the terminal velocity, the net force becomes 0. This then implies that dv dt is 0, which essentially means that velocity vt becomes a constant. Velocity increase has terminated and the particle henceforth would propagate at a constant velocity. The expression of terminal velocity is, where eta is coefficient of viscosity of the viscous medium, r is the radius of particle, g is acceleration due to gravity, rho is the density of particle, sigma is density of medium. For two solid spheres, let us call them 1 and 2. The density rho is same, they are falling in the same medium, so density of medium sigma is same. The coefficient of viscosity of medium is also same. The radii are r1 and r2. Their speeds terminate at different velocities, say v1 and v2. Their masses are density into volume. So it is m1 equal to rho into volume of first solid sphere. Similarly, m2 equal to rho into volume of second solid sphere. Given that v1 equal to 4 times v2. Let us put the expressions of the respective terminal velocities, that is for v1 and v2, to get, or r1 square equal to 4 times r2 square. This leads to r1 equal to 2 times r2. Now consider the ratio m1 by m2. It is r1 cube by r2 cube. Putting r1 equal to twice r2, we have the ratio to be 8. So option D is correct. We switch over to the next problem. A particle with time-varying mass where m0 and t are positive constants moves along x-axis under the action of a constant positive force F, and the time span is limited within. If the particle is at rest at time t equal to 0, then at time t its velocity v will be, and the options are option A, option B, option C, and option D. The answer: Newton's second law of motion is force equal to rate of change of momentum. We write it in one dimension, F equal to dp dt. So dp is F dt. Integrate. C is constant of integration. So P equal to, we can push F outside the integral since F equal to constant. So P is Ft plus C. At t equal to 0, particle is at rest, implying that velocity v equal to 0 and hence momentum p equal to 0. So c equal to 0. Thus p equal to ft. Again p is mv, so we have mv equal to ft. Put the expression of m to get. So the option C is the correct one.